Hi Year 11. This is going to be my first attempt at making a video that you can watch at home, write notes, and then we can save time in our lesson and spend our lesson doing examples. So today we're going to be talking about quadratic theory, or the theory of the discriminant. We know a lot about quadratics already. We know that we've drawn the quadratic function, y equals ax squared plus bx plus c. We've drawn lots of those, and when we draw it, we get a parabola. You should all be quite expert at this, but there will be some revision of this as we go through the topic. And we all know that when we make one side 0, we get a quadratic equation, the solutions of which are called the roots of the equation, and we've used that word before as well. In this video, we're going to talk about the quadratic equation and its roots. So, we all know how to solve quadratic equations, and we've had lots of experience doing that. Both simple algebraic kinds, ones that occur with trig equations. You should all be expert in solving quadratic equations, both by factorizing and by using the quadratic formula, which I taught you last year. You can practice singing the song if you like. Now, we know that not all equations have solutions because sometimes when we try and use the quadratic formula, we get a negative number under that square root sign. And in order to be able to evaluate a square root, the expression underneath has to be positive. So we call that expression underneath, b squared minus 4ac, the discriminant, and we give it its symbol delta, capital delta, which is a Greek letter. Delta for D, discriminant, because it will discriminate between those quadratic equations that have solutions and those that don't, and also it will discriminate between different types of solutions that a quadratic equation can have. I know we talked about this already last year, but let's have another look at this. So, clearly, the solutions of a quadratic equation can be given by the formula, the quadratic formula, and I've rewritten it as minus b plus or minus the square root of delta over 2a. So if delta is less than 0, the roots can't be real, or we say the roots are imaginary. If delta is equal to 0, then that square root disappears and we only get the solution minus b over 2a. So we say there is only one root, or sometimes we say there are two roots but they're equal to each other. If delta is positive, there's going to be two distinct or different real roots. And if delta is greater than or equal to 0, there will be real roots, sometimes equal, sometimes different. If delta is a perfect square, then the square root will disappear again, but we'll get two different roots, but they will be rational because there will be no surds in the answer. I'm going to put this PowerPoint up on Ellie. I want you to copy those notes and you need to learn this page. So, what kind of problems can we now solve? I'm going to go through a few of them and get you to try them and then put the solutions up. Let's have a look at the first one. Example 1. Find the discriminant and hence discuss the nature of the roots of each of the following equations. So I'm going to give you a minute or so to consider this and do it for yourself. Okay, that was a minute. So let's have a look. For the first one, your discriminant is going to be 9 plus 24. That's 33. That's positive. And this means that that equation has two distinct real roots. If we change the sign and make it x squared minus 3x plus 6 equals 0, you should have got that delta is minus 15, which is less than 0, so the roots are imaginary. And for the following one, you're going to find that delta is 49, which is a perfect square, so this equation has two rational roots. Hope you got that all right. Let's go on to the second one, and I'll give you a minute to do this one as well. For what values of k does the equation x squared plus 2k plus 2x plus 9k equals 0 have equal roots? I hope you can all start this equation, or this example at least. I'm going to give you 40 seconds to write something down about it. Okay. I hope you all started off by saying some theory. What would be the theory that you would want to say? You would want to say that for equal roots, delta equals 0. And always try and write some theory in this kind of an example. So we write down the discriminant. It turns out to be 4k squared minus 20k plus 16 equals 0, which is, I hope, what you got. And that means that k is 4 or 1. Hope you all got that right. Let's try another one. And think about what might be the first thing you would do in this equation. Or in this example, where it's asked you for what values of p, x squared plus p bracket x plus 1 equals minus 3 will have real roots. What do you think the first job is going to be here? I think it might be to rewrite this equation so it looks like a quadratic. Anyway, have a go. I'm going to give you 40 seconds from now. That should be enough. Let's have a look at the answer. Firstly, please notice that I have not written this in the same form as we wrote the original theory. So our first job is to rearrange it. And when we do, we're going to get x squared plus px plus p plus 3 equals 0. So our A part will be 1, our B part will be p, and our C part will be p plus 3. Then we write our theory. We get this quadratic that you can see in front of you greater than or equal to 0. We've done that kind of inequality 10 million times. You should then easily get the answer. Okay, here's a different kind of example. This is one in which I've asked you to show something. Show that the equation 3px squared equals 2px plus 3qx minus 2q will have rational roots for all real values of p and q. So there's two things you will notice here. The first thing is that it says show, which means you have to write some words. The second, that once again, this equation is not quite in the form that you would want. Again, I'm going to give you 40 seconds from now. Shall we have a look at the answer? Got to put it in the form ax squared plus bx plus c equals 0. Got to write some theory. For rational roots, delta must be a perfect square. Find your delta. Oh my God, it is a perfect square. Hence the roots have to be rational. I hope all of you got that right. Here is our fourth example. For what values of k is the line y equals kx minus 1 a tangent to that curve, which happens to be a parabola? Very tempting to use calculus, isn't it? But this is not a calculus question. It's a question that's asking you, when will that line just touch that parabola? And when you think about it, a line can either not intersect a parabola, intersect it in 2 points, or in 1 point. I'm going to give you 40 seconds to think about this example. So if it's just going to touch that parabola, then when we solve their equations simultaneously, how many solutions would I want to have? I would only want to have one solution. Again, you see that when I solve their equations simultaneously, I get a quadratic because it's where kx minus 1 equals x squared minus 2x. When I rearrange that, I get the quadratic x squared minus 2 plus kx plus 1 equals 0. I'm going to pause here so you can see how I got that. Use a pen and paper, get it for yourself. If I only want one solution, I want my discriminant equals 0. This means that k can either be 0 or negative 4. So, homework. I hope you've enjoyed listening to this video. I'm putting the PowerPoint up on Ellie, and I would like you to copy these as notes to think about the examples and be ready to do a whole lot more in our lesson. Thank you for listening.